Hello student, myself Sanjay Sharma, your physics teacher, again coming here with my new topics of electrostatic unit, and the topics are Coulomb's law in vector form, units of charge, relative permittivity or dielectric constant. In your 11th class, you all have studied about Newton's gravitation law. In that law, Newton has taken 2-point masses, and basically Coulomb's law is the electrical analog of Newton's gravitational law. According to Coulomb's law, when 2-point charges are kept at a distance r apart, then the force of interaction between the 2-point charges is always directly proportional to the magnitude of the product of two charges and inversely proportional to the square of the distance between them. If we combine both the equations, then we can write F is directly proportional to Q1 Q2 upon R square. As we all know that when we want to remove directly proportional sign, then we have to use any constant. And here the constant is small k, which is called as positive constant of proportionality, or you can say Coulomb's constant. Here the value of small k is depend upon the unit of measurement and the medium between the 2-point charges. In vacuum, the value of small k is 1 upon 4 pi epsilon naught. And in any other medium except vacuum, free space and air, the value of small k is equal to 1 upon 4 pi epsilon. Here naught will not come. Why? Because the medium being changed. When the medium being changed, then its value will also be changed. So see here, the ratio of epsilon and epsilon naught is called as epsilon r, which is known as the relative permittivity, which can also be called as dielectric constant. So the formula in vacuum for force equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and in medium except 3 medium, which one? Air, vacuum or free space. Except these 3 medium, if any other medium is there, then the formula will be F equals to 1 upon 4 pi epsilon naught epsilon r Q1 Q2 upon R square. Here the value of epsilon naught equals to 8.8542 into 10 raised to the power minus 12 Coulomb square per Newton per meter square. If we put the value, this epsilon naught, in the value of k, then the value of k mean 1 upon 4 pi epsilon naught become approximately 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Now the Coulomb's law in vector form. Basically these are the small questions generally comes in board exam. The question comes like the Q1 Q2 is more than 0 or Q1 Q2 is less than 0. What does it signifies? Then I am telling you. Q1 Q2 is more than 0 mean the product of Q1 and Q2 magnitude is equals to positive. It is possible only when both the charges Q1 and Q2 are negative, or both the charges Q1 and Q2 are positive. Because when the positive they multiply to each other, then the product will be positive. And if the negative they multiply to each other, then the product will also again positive. And if the two positive charge or two negative charge, they are lying at some distance, then the force of interaction between the two charges will be repulsive. And if Q1 Q2 is less than 0, it means the product will be negative. It will possible only when Q1 is positive or Q2 is negative, or Q1 is negative or Q2 will be positive. So in this condition the force become attractive. Now, units of charge. In SI system, the unit of charge is coulomb. The 1 coulomb of charge is that charge which, when placed at rest in vacuum at a distance of 1 meter from an equal and similar stationary charge, repel it, and it repelled by it with a force of 9 into 10 raised to the power 9 Newton. In CGS system, the unit of charge is state coulomb or ESU of charge. In CGS electrostatic system, the small k becomes equals to 1 upon capital K, where capital K is dielectric constant. For vacuum, capital K is 1. The formula becomes F equals to Q1 Q2 upon R square, and here we can define 1 state coulomb as we have defined 1 coulomb. Now, relative permittivity or dielectric constant, how can we define it? The relative permittivity can also be defined as a ratio of absolute permittivity of the medium to the permittivity of free space, which can be written as epsilon upon epsilon naught. And the dielectric constant or relative permittivity can also be defined as the electrostatic force between two charges separated by a certain distance in vacuum to the electrostatic force between the same two charges separated by the same distance in the medium. That is, dielectric constant equals to the force in vacuum between the two charges divided by the force between the two charges when the medium will be there. Dielectric constant has no unit. So this was all about related with my topics. See you later, and I will come again with some new topics of electrostatics, and goodbye.